This paper is titled Spatial Augmented Reality, Visibility and Line of Sight Cues for Building Design, and the authors are James Walsh, James Baumeister and Bruce Thomas, and we're from the Australian Research Centre for Interactive and Virtual Environments at the University of South Australia. CADwalk is a commercial system that provides life-size one-to-one scale CAD visualization. Effectively, it's an empty warehouse with multiple floor-facing projectors where end users can bring in and visualize their plans at life size. One of the issues for this is whilst we can visualize the plans at one-to-one scale, we can't easily show objects' heights on the floor. To alleviate this, the system has a large-scale wall display to show a perspective-correct 3D rendering of the space. Depending on the application domain, visibility for the plan can actually mean life or death. If we're designing critical control rooms or military spaces, if we don't have appropriate line of sight in the space, it could actually result in someone's death or injury. So the problem that we were looking at for this work was, given the floor projection is separate from the 3D wall display, how can we support queries such as, is location A visible from location B? And more fundamentally, how can we easily communicate lines of sight in this space for both novice and expert users alike? Because when design reviews are conducted within a CADwalk space, it has end users from across the spectrum, from a CEO all the way down to the people that will actually be utilizing the space. In exploring related work, Spatial Augmented Reality, or SAR, has been shown to have different constraints versus head-mounted display or handheld AR, which is what people traditionally think about when we discuss augmented reality. And SAR has been used in collaborative scenarios before, including previously in building design and planning. It has also been shown that it can reduce cognitive load for certain tasks. Ilidia al. explored displaying users' relative position with spatial cues in extended reality using these projectors. And previous work in tablet-based building layout collaboration has found that even casual users engage in more than just positioning objects within the building. What we need to be aware of, though, is that the spatial cues, whilst they've been explored in prior work, when they communicate an object's relative direction, this is not the same as communicating an object's visibility and line of sight. They are two separate things. We developed a number of different visual cues that we evaluated as part of our work, but they needed to fulfill three main requirements. They needed to work within the existing CADwalk system. They needed to support a range of use cases and scenarios, for example, critical control rooms, military and domestic applications. And again, they needed to be intuitive for both novice users and expert users in the system. We explored two approaches. One was a quantified cue that was used per object within the space, and we refer to this as the fuel indicator. The other cue was a continuous cue across all objects in the scene that we refer to as edge highlighting. The fuel indicator allows users to select an object using a handheld controller. An 8-segment bar then appears at the user's feet, indicating how visible that selected object is from their current viewport. As the user moves around the scene, you can see that the bar either fills up or becomes empty to indicate the object's visibility. An arrow marker is placed in the outline of the selected object and faces the user as they move around the space to indicate that that is the object that is selected and that is facing back towards the user. And the application for this will be explained in a couple of slides' time. The second cue was edge highlighting, and effectively what we had for this was the virtual torch shining from the user's handheld controller. This then highlights all the edges of the objects on the floor that are visible from that controller's location and view frustum. Originally we had this attached to the user's head, so that wherever they were looking, they could be able to see the edge highlighting for what was visible from that current location. However, we found that this was very distracting for users, and quite often people would be looking in a separate direction to potentially where they're wanting the cue to actually appear. So we slaved it to the user's hand controller rather than the user themselves. The other thing that we were interested in exploring was this idea of having an inside-out view versus an outside-in view. Traditionally in this space, if we're looking at whether a supervisor, in this figure, X, can see their subordinates A, B, C, and D, we can refer to this as an inside-out view. But what about if we invert this approach and we have an outside-in view? So instead of seeing if the supervisor can see the subordinates, we explore whether all the subordinates can see the superior. Both approaches have different fields of view, but the outside-in approach means that all fields of view now have a common and shared focus. So the question was, can we utilize this for evaluating multiple lines of space within the CADwalk environment? We paired this with the fuel indicator. So upon selecting an object in the space to place a fuel indicator, a virtual camera is also placed at that location. The camera is then displayed on the end wall, looking back at the user as they move around the space. The user's controller is represented as a red sphere on the wall to give the user an understanding of where they are based on the virtual camera's rendering. The user can place up to 4 virtual cameras in the place based on where they select fuel indicators on the space. We conducted a user study to evaluate our work, with the primary goal of evaluating the 2 indicators, and a secondary goal to explore if our outside-in camera approach was useful for end users. The task required users to select a location within a mock-up office scenario that maximized the visibility to 4 objects of interest. There may not be a location in the space that had 100% visibility for those 4 objects, so it was an optimization task where they had to pick the best location, not the perfect location. The datasets that we used were various room shapes and configurations based on various office configurations. You can see on the right-hand side there a number of different mock-up shapes based on desks, filing cabinets, pillars, office dividers, etc. We had 5 different conditions, and they were broken down across 2 main aspects. The first was the floor indicator. So we had the baseline condition, which was the original catwalk visualization. We then had a single fuel indicator. We then had multiple fuel indicators where the user could select up to 4 objects at the same time to view the different indicators. We then had the edge renderings, and then we had another condition that also utilized multiple fuel indicators. The second aspect for each condition was related to what was shown on the wall for the camera placement. So for the baseline, this used a fixed camera in the top left-hand side of the space, and this was looking back at the layout. In a traditional catwalk session, they would have a session operator controlling this camera. Because we were trying to have end users take control of the system, we had a camera located at a fixed position showing the entire space from that same location. The single fuel indicator, the multiple fuel indicator, and the edge conditions all shared the same inside-out camera that was attached to the user's handheld controller and could be placed at any space in the environment. The 5th condition, that had the multiple fuel indicators as well, then had up to 4 outside-in cameras that could be placed at locations selected by the user. The data that we collected was participant location, the direction they were looking at for their head to evaluate whether they're looking at the wall or the floor, the location selected by the participant as being the optimum location, the visibility of the 4 objects of interest from that location, how often they placed or removed the fuel indicators if that was applicable for the condition. We then performed the system usability scale and collected experiences and preferences in the space. For full results, please see the paper. For visibility, multiple fuel indicator had significantly higher visibility compared to the other conditions, and visibility significantly improved across all the conditions over time as users became more familiar with it. For completion time, baseline and edge were shown to be significantly faster, however they did not differ from each other. In looking at users' movement through the space, multiple fuel indicators with a traditional inside-out view had significantly less movement than a single fuel indicator. However, there was no variation for the other conditions. For mental effort, baseline had significantly higher mental effort than the multiple fuel indicator with the traditional inside-out view. For SUS, all conditions except the baseline received above average SUS scores. And again, I refer you to the paper to see the full results. For user preference, all conditions were preferred by users over the baseline. The multiple fuel indicator outside-in condition, this is the new approach, that was most preferred, but was only significantly more so than the single fuel indicator inside-out. For takeaways, we can see that the baseline leads to faster completion time with less overall movement, which is as expected. The baseline and edge cues, however, performed worse for visibility, and all conditions were preferred over the fundamental baseline, showing that we can actually improve catwalk. There is this trade-off between time and performance for visibility versus the mental effort required for those. So we can have a very quick scenario, but the performance will be low, i.e. low visibility in the space, and there'll be a high mental effort in that space. Results show that there is a preference for the fee-based conditions versus the edge and the baseline, which is unsurprising given the quantitative nature of the fuel indicator. The alternative views that we introduced for the camera placement showed promise outside of the traditional outside-in view, and future work should seek to address this as a full study in its own. We only partly explored this as one condition to reduce the number of conditions and thus the length of the study for participants. We'd like to acknowledge that this work was funded as part of the Innovative Manufacturing CRC, as part of the Australian Government's Department of Industry, Science, Energy and Resources Cooperative Research Centres program. The authors would also like to thank Catwalk Digital for their support. Thank you for listening.